Hello and welcome back to my channel. Today we're going to be talking about the comparison test for convergence. It's also can be some about divergence too. So we're going to be talking about what's called the comparison test. So when we look at some of these series, we have nice series and then we have some not so nice series. So in our case, if we get something like the summation from n equals 0 to infinity of 1 over 2 to the n power. This is a really nice thing. It's a geometric series. We can figure out if it converges or diverges just looking at it. But if we were to get something almost identical, so the series from the summation from n equals 0 to infinity of, we still have 2 to the n power, but the moment I put n on top, it's not geometric anymore, and we don't have a real easy way to kind of deal with it. Another example of that would be if we have the summation from n equals 0 to infinity of 1 over n cubed. This is a p-series. We can tell really easily if it is or is not going to converge versus if we have n cubed plus 8. We can't really do a lot with the plus 8. It's not really a p-series anymore. And especially if I have an n on top. I could deal with it if it wasn't n cubed plus 8, but it is. So we're going to use these two comparison tests to kind of help us out with this. So option 1, the direct comparison test. So the direct comparison test has a couple requirements. And by a couple, it really has one big one. And then based off of what we know and what we can find out, will tell us what's going on with it. So we need two series here, so two equations that we're going to be working with, a sub n and b sub n. We are going to pick one of them, and the other one's going to be what was given to us. And we need b sub n to be greater than or equal to a sub n, and we need everything to be bigger than 0. So every term in our sequence has to be bigger than 0. So it has to be a positive value. If the series from n equals 1 to infinity of b sub n converges, then we know that a sub n has to converge, that series. And then on the other hand, if a sub n diverges, b sub n also diverges. So like I said, one of the things that we want to know is that we are going to be choosing one of those functions. The other one is going to be the one given to us, but we get to choose which one's which. And that's going to be based off of what we potentially think might happen or what the problem can kind of tell us. The other thing that we have to kind of be careful of is we have to be able to know which one is bigger or smaller. So let's talk about why these kind of work out the way they do. And the best way that I can kind of explain this is to talk about airplanes. So if for some reason we have two airplanes here, and for some reason they are right on top of each other, which really wouldn't happen, but we're going to pretend like it does. So this first airplane would be our b sub n, that's one on top. The second one would be a sub n, and that's because b sub n has to be bigger than or equal to a sub n for every value. So if we look at this first option, converges. So if b sub n is going to converge, so our terms are going to go to 0 after a while, we're looking at something like this. If this is the case, that means a sub n, which is always smaller than b sub n, is going to be following the same pattern. So if b sub n converges, that means a sub n also has to converge. If we do the exact same thing, but with our diverging, with my Great Plains. So if we have our same things, b sub n, a sub n. In the second one, it says if a sub n diverges, then b sub n diverges. Well, if a sub n diverges, that means our values are not going towards 1 or 0, so the terms in our sequence might be looking something like this. B sub n has to always be greater than or equal to, so I have to kind of follow this same thing even if it's like really close. So if A sub n diverges, B sub n has to diverge. Where it kind of like falls out is if we kind of mix up those two things. So if B sub n diverges, so it's going away from 0, A sub n just has to be smaller than B sub n. It could go either way. It could go converging or diverging or converging. And we don't know which one it's going to be because B sub n is above and we can't tell which one's which. The same thing is going to happen if we look at it the other way around. So if A sub n converges and we know that, B sub n could converge, but it could also diverge. It's not like forced into doing the same thing. So when we're looking at this, we kind of want to think of it as airplanes to kind of help us decide or remember which one goes with which. So we're going to look at this first problem and kind of decide what's going on with it. So we have the summation from 1 to infinity of 1 over 2 plus 3 to the n power. So the first thing that we want to do is we want to decide on a series that would make sense. We want generally something really close to what we have because it's going to make our lives a little bit easier. So 1 over 2 plus 3 to the n power, we're going to keep 1 on top. 1's not causing us a problem. The 2 is the thing that's causing us a big issue here. So we're going to kind of pare it down, and we're going to try B sub n equaling 1 over 3 to the n power. So we're going to try this one. That means that we're looking at the summation from n equals 1 to infinity of 1 over 3 to the n power. If I look at this, this could also be written as 1/3 to the n power, which means this is a geometric series. Not only is it geometric, we know that the absolute value of r is equal to 1/3, which happens to be less than 1. And then we need to remind ourselves, when the absolute value of r is less than 1, we know that it converges. So this series converges. Okay, so reminding ourselves when we look here, if B sub n converges and we're making this B sub n, we want our value to be B sub n because it's converging. If we looked at this and said, hey, this is diverging, we're going to say instead of B sub n, that function's A sub n. So we can pick that later on to try to decide what we are dealing with first and then kind of go from there. What we need to show now is that B sub n, the function that we have now decided, 1 over 3 to the n power, because it converges, we need to decide that it is bigger than or equal to A sub n for all values. So now what we're going to do is we need to compare (1 over 2 plus 3 to the n) and 1 over 3 to the n power. So one of the things that we need to do is we need to kind of set it up in this exact thing that we need. So one thing that we want to look at first is to make sure that these are both bigger than 0. We have a positive value. This is always going to give us a positive value, even when we put in a negative value for n, but we're not going to because we're looking at 1 to infinity. And then we're adding 2 to it, so it's going to be positive. We have a positive number on top, This is going to be positive on bottom. So both of these are a positive divided by a positive, which means it's going to be bigger than 0. So what we need now is a sub n has to be greater than or less than or equal to b sub n. We said b sub n was 1 over 3 to the n, which means a sub n has to be 1 over 2 plus 3 to the n power. And this has to be true for n greater than or equal to 1. It does not have to be true for negative values or 0. Okay, so now what we're going to do is we're going to be multiplying by the denominators on both sides. When we do that, it's kind of look like we flip some things around. So I'm going to multiply both sides by 2 plus 3 to the n power. That means our 2 plus 3 to the n is going to be on this side. If I multiply 3 to the n on both sides to get rid of that denominator, we're going to have a 3 to the n on this side. And then because we just multiplied by positive numbers, that stays in the same position. It doesn't flip. So 3 to the n is less than 3 to the n plus 2. This is a true statement. That means the one above it, 1 over 3 to the n, is indeed bigger than or equal to 1 over 2 plus 3 to the n. And that makes sense because 1 over 2 plus 3 to the n is going to have bigger numbers in the denominator than 1 over 3 to the n. And when we take 1 dividing it by something that's bigger, it's going to be a smaller number overall. So what we now can say, because we have now proven that a sub n is less than or equal to b sub n, and we know b sub n converges, what we can say is by the direct comparison test, the summation from n equals 1 to infinity of 1 over 2 plus 3 to the n converges. So the big thing here is we decided that 1 over 3 to the n power was going to be easier to work with. We can say it's a geometric and it converged, and then kind of worked our way around.